Okay, we're back. Unit 7, Lesson 3. This is the last video for this lesson. We're going to go over problems 3 and 4. And as promised, I'm just going to get you started and then kind of pause the video and see how you do on the questions on the bottom, because they're very similar to what we did in examples 1 and 2, in problem 1 and 2 for pages 1 and 2. Okay. So we have a triangle here, and in order to find the area of a triangle, if you will remember back from some geometry that you've had, okay, area of a triangle is 1/2 the base times the height, okay? Now in this triangle, one of these is your base, one of this is your height. This is not even counted in that, okay? So we have x squared. We'll call this one the base, this one the height. It really doesn't matter which one is which, because you're going to multiply them, right? So our area in terms of x is going to be 1/2. Our base is going to be x plus 2 times the height is 2x minus 1. Okay, so the first thing we have to do is multiply these two that are in the parentheses, and then we're going to have to go back and then multiply everything by 1/2. Okay, so we have a couple of things here we have to do. So the first thing we're going to do is take this x plus 2 and multiply it times 2x minus 1. Now we're going to use the box method, and I already had one drawn here because, I'm just trying to save time. So we have 2x times x is 2x squared. Then I have 2x times 2, that's a positive 4x. Then I have x times a negative 1, that's a negative 1x. We have 2 times a negative 1, that is a negative 2. Now, if you recall, I had to bring these out of the box, and these are the only like terms that we have. So we're going to bring these out. We have 2x squared. 4 minus this 1. Remember, there's a 1 there. 4 minus 1 is 3x, and then minus 2, right? Okay, and so also, if you recall, we can't forget about this 1/2, right? So we have area is equal to 1/2 of this, okay? Okay, so we had the 1/2 times all of this, right? So we multiply this 1/2, we have to distribute it. And when we do that, we have to distribute it or multiply it by everything that's inside these parentheses. All right, so I multiply it times that 2, I multiply it times this 3, I multiply it times this negative 2, okay? Yeah, you can use the box method. You're going to have one box times 3 boxes, right? So I have 1/2 times 2. 1/2 times 2 is 1 divided by 2 times, not divided by, times 2 is 1, right? Yeah, okay. So I have 1x squared, and then 1/2 times 3 times 3 is 3 over 2, right? So plus 3 over 2x, then 1/2 of negative 2 is a negative 1. Now you can use your calculator to figure all that out, can you? All right, so the area of the triangle in terms of x is x squared plus 3/2 x minus 1. All right, so we're going to have to use that, right? And remember, you have a calculator when you're doing this. Don't worry about that fraction there, okay? Now, the perimeter to this triangle. We don't have a formula, do we? Other than perimeter means to add all the sides. We can do that, right? Oh, look, that's what this is going to equal. Add all the sides. Perimeter formulas equal, add all the sides. So my perimeter is equal to 2x minus 1 plus x squared plus 5 plus x plus 2. Oop, almost forgot my plus sign there. If you separate those, there's a plus. That's a positive x. This is a positive x squared. Okay? All right, so, wow, I have that down there. Let's put some columns here, because I have different terms, different types of terms. I have x squareds, I have x's, and I have numbers. And we're just adding terms, right? So I have a 2x that goes under my x column. I have a negative 1 that goes under my numbers column. I have an x squared that goes under my x squareds column. I have a plus 5 that goes under my numbers column. I have a positive x, that's a 1x. I'm just going to go ahead and put that 1 there, so don't forget that. And then I have a plus 2. I'm going to put that right here under my numbers column. Now I have everything I can add up, right? So I don't have anything to add to the x squared, so I'm just going to put x squared. Okay, I have 2 plus 1. That is a positive 3, so plus 3x. All right, and then I have 5 plus 2 is 7, minus 1 is 6. All right, so in terms of x, my perimeter of that triangle is x squared plus 3x plus 6. All right, so what I want you to do is I want you to use this information. Let's do the area of the triangle when the value of x is equal to 6. I'm going to pause the video, and I want you to come back and see how you did. All right, so how did you do? Hopefully well. We used the area formula in terms of x, which is x squared plus 3 over 2x minus 1. They told us that x was equal to 6, so we plugged in that 6 for the x. Everywhere there was an x, we put a 6 in its place. We ran that through the calculator, and when we calculated that, we got a 44. Hopefully you did well. All right, let's try the perimeter of the triangle when they gave us x with a value of 2. All right, come right back. Okay, how did you do? All right, so we used the perimeter in terms of x squared plus 3x plus 6. Right here, we substituted this 2 in there for the x. Everywhere there was an x, we put that 2 in. Okay. All right, and then we calculated that in our calculator, and we got a 16. Hopefully you did the same thing. All right, so this time we're going to find the area of the triangle. I know, but they gave us the area of the triangle. They told us it was 21 square inches. Now we're looking for x. Okay, let's see how you do on that one. Okay, I am going to give you a hint on this one. Since our area has x squared in it, you might want to graph and analyze your graph, okay? All right, go with that. All right, so we're finding the area, we're finding the value of x. All right, so if we solve for 0, we took this, took the 21, we plugged it in for the area, solve for 0, we would get x squared plus 3 halves x minus 22, because we have negative 1 minus 21 gives us negative 22. We graph that. This is what we get. We're going to analyze our graph, menu, 0, click, drag, click, menu, analyze graph, 0, click, drag, click. We only have one real world answer over here, right? We had a negative 5.5 and we had x equals 4. So our answer would be x is equal to 4. Let me show you something real quick. I want to do this just real quick. I'm only going to do it one time. If I didn't want to add these up, let me show you what you can do. X squared plus control divide. Let's do the 3 over 2 x. Go to the right, do x. Let's see, the first one was minus 1. If we were subtracting 21 from both sides, guys, I can just subtract 21, and look what happens. When I graph this, it should land right on top of that blue graph, and it does. You can do that and find the zeros of that one. It's the same exact graph. It's just calculating it for you. Okay? All right. So this is the 0. It is the solution. It's the value of x. Okay? It is the real world answer. Okay? All right. Let's do the same thing with the perimeter of the triangle. If I confused you on this part over here with the red graph, you know what? Go back and listen to that part again if you really like it. Okay? I'm going to pause the video. Let's find the value of x if the perimeter of the triangle is 7.75 millimeters. Remember, the perimeter has an x squared in it. You're probably going to have to graph. Let's see how you did. All right, so this is our real world answer. X is equal to 0.5. Check this out and see how I got that. Here's my graph. You can pause that and look at that for a minute. We're going to analyze the graph. Menu, analyze, 0, click, drag, click. It's the only one that's positive, right? I'm going to go ahead and analyze and find the negative, right? So my value of x is going to be 0.5. All right, so that is my real world solution for x if the perimeter of the triangle is 7.75. All right, so we have some more on the second page. All right, this is problem 4. Okay, so what I want you to do is I want you to find answer these questions. We're going to work through these questions, okay? What process would we have to use to find the area of the composite figure? What would you have to do? And then what process would we have to use to find the perimeter of the composite figure? And then if the value of x is 3, what would the perimeter of the figure be? What I want you to do is I want you to answer these 2 questions first. I'm going to pause the video and come back and we'll have a short, brief conversation about those, okay? Okay, real quick. The process that we would have to use to find the area of the composite figure is we would have to find the area of the square plus the area of the triangle, okay? So once you think about how you would do that, you'd have to find both of those. So you're going to have to do that. And then what process would you have to do to find the perimeter? Well, you're going to have to add all the outside edges. So I went ahead and set you up a T-chart right here. So you have to figure out what are all the outside edges, just the outside. We don't need this one right here, right? All right. So think about that. Find out what each one of those is in terms of x. All right. And so have that ready so that whenever we come back, we'll be ready to move on. Okay. Well, a lot of work here. All right, so to find the area of the composite figure, we first had to find the area of the square. We multiply 2x minus 2 times itself. The area of the square is 4x squared minus 8x plus 4. You can pause the video and check that out. Then the area of the triangle. Here's the work for that. Remember, you have to do 1/2 of the base times the height. You can pause that and look at that. Then you add them together. Here's the work for that. And once you get that, here is the total area of those, which is 5x squared minus 10x plus 5. So we're going to need that later, okay? So I'm just going to highlight this in a different color, okay? We're going to need that. All right, so then we need to find the perimeter, right? All right, that means add all the outside edges. So as we'll go through these, I'm going to show you what I did. So we did 4x plus 5. There's that one. Okay, 2x minus 2. There's one of those. Here's another one. I'm going all the way around the outside edges. 2x minus 2, and then the x minus 1. Now, I'll put them there under the x's and the numbers. Put them under those columns. When you add 4 plus 2 plus 2 plus 2 plus 1, don't forget that's 1, you get 11. So this is 11x. If you add all of these integers, you end up getting a negative 2. What this is the perimeter of that composite figure. All right? All right. So what I want you to do is I want you to figure out what the value of x, with the value of x being 3, what is the perimeter of the figure? And then if the value of x is 5, what is the area? We'll pause the video and come right back. Okay, and just like we did on the last couple of few problems, all we are going to do is put in the value of x wherever there's an x. In this place it's only 1. 11 times 3 is 33 minus 2, so that gives us 31. On the area, the value of x is equal to 5. What would the area be? We're going to replace every x with a value of 5. Here's an x, here's an x. We've replaced it with 5. We put it in our calculator. It gave us 80. Right? Last 2 questions. All it wants is what formula could be used to determine the area of the figure regardless of the value of x, and the formula of the perimeter regardless of the value of x. Guys, we already have those. Come back and find out. So we already did those, right? Because it saves us some time whenever we can think that way. All right? So we just made us a formula. We use those to answer the questions before that. All right. That's it for problems 3 and 4. Y'all did great. All right. Have a great day.